Good evening everyone, this is Vrushali. In my previous sessions we discussed about these practicals like practical number 1 based on searching and sorting, practical number 2 based on infix to postfix and prefix conversion, practical number 3 based on circular queue, 5 which is based on binary search tree and practical number 9 based on heap sort. I have mentioned the complete practical videos link in below description box. We also discussed previously complete FDS as well as DSA subject playlist. I have mentioned the complete playlist in below description box. Now, in today's session, we will discuss about the next practical which is based on threaded binary tree. We also discussed theoretical concept of threaded binary tree previously. Now here just review the concept. What exactly threaded binary tree? Threaded binary tree, they apply the logic of binary tree. Means all the smaller values than root node which is stored in left subtree and all the greater value than root node which is stored in right subtree. This is the first thing. Second thing is in this particular node it divided into the three part. The first part stored address of left node. In between there is a value or information. On the right side they stored address of the right node. That's why in this one node they divided into the three parts. Clear? Now here A, left side they stored address of B. That's why they points to the B node. Similarly in B, this node on left side they stored address of D, on right side they stored address of E. That's why it points to the D and E node. In this D, E, F, G, these are the leaf node. There are no any further node present in this binary tree. That's why their left and right side pointers stored the information null. Clear? This is the concept of threaded binary tree. They stored of address of previous or as well as next node. That's why we use threaded binary tree for linking purpose. Now, in today's practical, we will discuss about practical number 6 based on threaded binary tree, and their aim is to implement in-order threaded binary tree and traverse it in in-order phase. The first step is you need to use header files because all the built-in keywords or built-in functions have imported from these header files. That is hash include standard C++.h and hash include iostream.h. These are the header files. Now the second step is you need to declare one node. So for node declaration purpose we use structure because in every node particular address have stored, right? So you need to declare struct and name of the node like struct node. Now in this struct node you need to declare two variable, two declaration. First, struct node pointer left and pointer right. It means that see here in this node pointer left stored address of B and pointer right stored address of C. That's why we use pointer here. So this is a pointer left and pointer right, and next is integer info. Info means value stored in particular node which is either in integer type or in character type. Clear? This is a declaration. Now next thing is boolean L thread and boolean R thread. See here in this particular image. In this A, on right side, address of C is stored. That's why their boolean R thread is true. Means they stored the address of further node. The thread is present, right? Suppose in this particular A on right side, there is no any node is present. Means their boolean R thread is false. Clear? So basically, it indicates that thread is present or not. If boolean L thread is true, means L thread is present, and false means thread is not present. Clear? So this is the first declaration part. Now after that program always start with the main function. See here, this is the starting of the program. So initially you need to declare the struct node, that is root. Tree always start with the root, that is pointer root, which is null. Means your tree initially is empty or null. Clear? Now you need to insert different values in the particular tree. So for that purpose you need to call insert function. We declared insert function after the main function. Okay. So we declared insert and pass two parameters, root and their value. Root means our node. So we pass this value like 20, 10, 30 up to 13. So this value we inserted into the threaded binary tree. So that's why we call insert function. But after that, after inserting, you need to insert those value in order way. That's why after that you call in order function. Okay. So first we will discuss insert function. How to insert value in threaded binary tree. Okay. So while inserting, every time they call insert function. So we declared insert function. See here. After declaration of this struct node, after the header file, we declare here insert function. Okay. So the logic of inserting threaded binary tree is all the smallest value is on left side of root and all the largest value is right side of the root. Okay. So see here. First we declared a function that is struct node pointer insert because we stored the address. That's why pointer insert. And we pass here two parameters like struct node pointer root means your node and integer I key. I key means information, value that's stored in node. Now the first thing is node pointer ptr equal to root means your first inserted node always be a root node. The next thing is node pointer parent is equal to null. Root node not having any parent node, right? That's why their parent value is null. But suppose you declare here, see here, B having a parent node A means their pointer or PTR value is A. That is parent value, okay? And A doesn't having any parent value. That's why their parent value is equal to null. Clear? So PAR represent the parent, okay? Now next. So this is the two declaration first in insert part. Now next just focus on this if part. This is the first if condition. If I key is exactly equal to pointer of information. Suppose in your value pointer of information stored is 10 means your root node value is 10 suppose. Now you need to insert a next node and your next node value is also 10. Okay, means I key is equal to 10, that is your new inserted value, and already having a value root node is 10. So this is not a verified, right? So that's why it display the message printf duplicate key or they return a root value. This is the first if condition. See here in this image, suppose first we inserted A, on second time we also inserted A. So this is not possible. This is a duplicate value, right? So this is the first condition. Now the next if part. See here. If I of key means inserted value is less than pointer of information. Suppose your root node is 10 and you need to insert 5. So 5 is less than 10, right? So that's why 5 node is inserted on the left side, on left thread, right? And it moves to pointer of left means the left pointer of A points to the next left node. Clear? So this is the if part. Now see here in this image. See here, there is a root node is 6, right? And you need to insert a 3. So where 3 inserted, 3 is less than 6. That's why it inserted on the left side. And 6 left side pointer points to the 3. Clear? So this is the case. Now the next else part. So this is the opposite of this upper if part. See here. If See, if I of key value is greater than, here now less than, on less than it inserted on the left thread, okay? And suppose it is greater than of pointer of information means root value. So it is inserted on the right side, okay? That's why pointer of our thread is equal to false. Means only value have inserted. They doesn't have a next node, right? So pointer of right equal to pointer. See here in this image. Okay, see here. Now 8 value I have inserted. 8 is greater than 6. So it inserted on the right side. So 6 R thread means the right side pointer points to the 8. Clear? Now 8 doesn't having any other right side pointer still. We can't inserted 11 here. That's why it represent a false here. Clear? So this is a structure or this is a insertion logic as per the binary tree. If a searching value, inserted value is less than root node, it inserted on the left side, that is moved to pointer of left. And if inserted value is greater than root node, pointer of info means root node. Now it moved to right side, that is pointer of right. Clear? Next. Now this is a just a logic. Now at that time you need to create a first node. Okay, means you need to one create a node, then you need to insert those node in particular left or right side as per the thread. So for threading purpose, first you need to declare a one node. How to declare node? See here. Node pointer TMP, that is temporary node, means whatever the new node inserted, this new node called as temp, that is temporary, equal to new node. So new is a object. By using object, you create this node. This is the syntax of creating node. Node pointer temp equal to new node. Now this node having a total three parts. First, middle part, that is temp of info equal to I key. I key means their value. Now temp of L thread equal to true, means they have the left node, and temp of R thread equal to 2, means they also have the right child node. Clear? This is a key. Now see here in this particular image. Okay, see here. Temp of info equal to I key means A, that is A value. This node is called as temp, that is temporary. Okay. Temp of L thread equal to true, because A, they having the left child node, that is B, right? That's why they are L thread. This part equal to L thread, this is true. Now temp of R thread is equal to true. See here this C node. R thread of A points to the C, means equal to true. Clear? This is a called as node declaration. Means there are more than one node present in the particular tree. Clear? So this is a creation of node. Now next. So this is a main logic of threaded binary tree now. Okay. See here. First I will explain the logic here. Then it's easy to understand the program. See here. The threaded binary tree are divided into the two types, one-way threaded binary tree and two-way threaded binary tree, right? Now we focus on the one-way first threaded binary tree. Here, see here. This is the first A node. Left thread points to the B, R thread points to the C, right? Now B again having two nodes. Left thread points to the D and R thread points to the E. Similarly with the other nodes, right? And their in order traversal. In order traversal means left, root, right, in this way, in this particular sequence. I think I have already uploaded a video on traversing binary tree. So you must watch that video for in order traversal, how to calculate or how to generate in order traversal. Okay. So you need to apply left, root, right, this sequence. So this is a one-way threaded binary tree, simply. Now on the another way, this is a two-way threaded binary tree. So in our program, we use two-way threaded binary tree for in-order traversal. See here, there is a node. So their left side points to the B and the right side points to the C. Now C node is here. So C node again has two. So which one the previous node of C? Previous node of C is A. That's why this left side points to the previous node and right side points to the successor node. Okay. Predecessor and successor. Predecessor node means previous node and successor node means next node. Clear? So this concept we need to implement in our program. See here now. First, if there is only one node is present, that is root node, right? Root node doesn't having any parent node. That's why if parent exactly equal to null, then there is only one node. This root node is called as temporary node and their left side, right side both are null. This is the first if condition. Okay. Means there is only one root node. You can't insert any other node. Okay. Because there is only one root node. Clear? Now next else if part. Now just focus on this else if part. See here. If I key is less than parent of information, means suppose your particular value is less than root node. Now what happen here? See here. Just a second. Okay. Now just focus on this particular diagram. Okay. And with this code. Yes. See here. If I key is less than parent of information, means B value is less than A. Suppose. Okay. Now what happen? See here. temp of left is equal to parent of left. See here. Now focus on this E node, okay? Because these are the leaf node. We need to focus on leaf node only, okay? So temp of left. Now this node is called as temp. So temp of left which points to the parent node, right? See here, because they are having the previous node. So temp of left equal to parent of left. E left points to the B. Now next is temp of right equal to parent. See here, temp of right. Just a second. That is, sorry, on the left side node is here. Just a second. Focus on both part here. Okay. See here. Else if I key less than per information. See here. E. Suppose D is less than B. This D doesn't having any previous node, so it doesn't connected any previous node here. But D having successor node. See here. Temp of right. In this else part, temp of right equal to parent of right. Temp of right having a particular value have present, that's why it connected to the parent of right. See here, D of right is connected to the B, that is your parent node. Clear? Means simply what happened here, whatever the node have present, their previous node is connected to the parent node and their next node is connected to the successor node. Means their next node, whatever the next node is present. Clear? Now just focus on this F part. Their previous node is a C and there is no any successor node is present, right? So this is called as dangling pointer, right? Now just focus on G. G also having previous node, that is E, and their successor node. So G is a last node. There is no any successor node is present. That's why it is connected to their main parent. Okay. So same this concept applied here. See here. When value is less than root node, so their left part is connected to the parent of parent and their right pointer is connected to the parent. Okay. And their threaded are false because you need to display all the information all the thread. Okay. And last one is, see here. See, when value is less than root node, so their left part means parent of left part is connected to the temporary node. See here, A left part is connected to the B, means parent of left part connected to the B. Clear? Now the next else part is when information means whatever the node you inserted which is greater than parent of information. Suppose C is greater than A. That's why it's inserted on the right subtree, right? So here their left side is connected to the parent. See here, left side connected to the parent means temp of left equal to parent. See here, temp of left equal to parent. Means first you need to mention their left side, after that you need to mention their right side. Now the temp of right equal to parent of right and their right side is connected to the next successor node. Okay. So there are two concepts is used. This part is called as predecessor part and this part is called as successor part. Okay. And their L thread R thread value always be a false. Means you need to insert more values or more nodes in your tree. Clear? So this is a main logic of a particular threaded binary tree. Now after inserting all this value, they call in order function. Okay. See here. So first is insert function and after that in order function. See here, this is the in order function. Means you need to insert all the data in order way. See here, void in order struct node pointer root. Okay. We need to pass one parameter, that is your root node. If root is exactly equal to null, printf tree is empty. Okay. Or this is a C++ program. You need to just declare cout tree is empty here. Okay. So this is a root exactly equal to null. If there are null value is present, so display message tree is empty. Okay. Now the next. Now you need to mention in order. In order means left, root, right in this way. So first they check from the left side. Okay. Whatever the value have printed from the left side. See here. Just a second. Okay. See here in this particular image. We need to mention the in order of this left subtree. So they always start with the left node, that is 1, after that 3, after that 5, after that 6 in this way. Means left, root, right. Now left, root, right in this way. So this is a in order traversal path. So they always start with the left side. So similar this thing mentioned here. While pointer of left thread exactly equal to false. Means they start from this thing 1 because their pointer left thread is false here. There is no any left node is present, right? So they start from the 1. So after that pointer of left it moves to one by one other nodes, and if particular information is present so they display this particular information and they call in order successor function. Okay, means this void in order function just generate a in order way their path, means how to display the node left, root, right in this way, but every node in between thread is present. So this thread have counted by the in order successor method. See here, here we declare in order successor. Okay, see here. So struct node pointer in order successor. This function is declared. We pass one pointer here, struct node pointer. Now see here. In this particular image, see here. 1. We start from the 1 as per the in order route, as per the in order method. So in order, after that R thread is present goes to 3. See, pointer of R thread is exactly equal to true. Now they move to right side. Again they check on their any right side value have present, 5 is present. Now 3 to move to 5. So they continuously recursively check in order in successor or in order right side path. Okay. So pointer of R thread is exactly equal to 2. They return that particular value and display all the value which is connected to the threaded binary tree on right threaded side. Okay. In this way. Just a second. In this way. See here. 1, 3, 5, after that 6, after that 7, 8, 9, 11 and 13. So this is a particular path. See, at the end 1, 3, 5, 6, 7, 8. In this way the particular information they display. Okay, as per the in order traversal tree. And if there is no any right side value have present, so they mention left side thread is false. Okay, now they move to left side as per the pre-order way. Clear? So this is a complete logic of threaded binary tree. So what we discuss in this session, see here. First, header files. This is a header file. Now next, struct node. I will display the output. So next you need to declare one node here. Okay. Now third part is main function. In main function you need to call insert for inserting the value, and by using insert method we declare one insert method is here, and we need to declare insertion part left side smallest value, right side greatest value, right? So this is the logic of insert method, and this is a threaded binary tree. That's why we create a thread as per the logic, right? Now next in order method just give the path like left, root, right to the particular tree, and there is a in order successor method. They display each and every members or nodes in the particular tree, right? So just execute the program, compile. Now run. See here, the output is just see whatever input is. Okay, our input is in order way. Okay, our input is unsorted way. See 20, 10, 35, 16, 14, 17, 13. Now it display the output in sequential way or in order way like 5, 10, 13, 14, 16, 17, 20 and 30. So this is a in order threaded binary tree, right? So this is a complete information about C++ implementation of threaded binary tree. So you can revise this program as per this particular image or as per the particular diagram. So it's easy to understand to revise the program and study the program. So all the best. Thank you.